Hi everybody. As we are working through learning Python, I have some online tutorials that will help you understand what Python does. The concepts are very similar to what we're working on in MATLAB. We have Boolean values. 10 is greater than 9 is true. 10 is equal to 9 is false. So anytime we have a condition, the condition can either be true or false. These are short little tutorials. As you can see, we're pretty much done already. So please go through those tutorials. It'll be very helpful for you. Now let's take a look at a program. I'm going to zoom in just a little bit. We're getting a float from the user. Is the number positive, 0, or negative? If the number is greater than 3, that's true. We have the result of is a positive number. If it's equal to 0, then it's 0. Otherwise, it's a negative number because there are no other choices. So one of the ways to think about decisions in Python or MATLAB is you're eliminating choices. If we already eliminate above 0, we never have to test for above 0 again. Once we've eliminated 0, we never have to test for 0 or above 0 again. All that is left is a negative number. Let's run this little guy. Takes a minute the first time we're on. You can see it's connecting and doing all its mumbo jumbo. Okay, so 1 is greater. We press enter. It is positive. Let's run it again. This time we'll put in 0. It is 0. 0.0 is 0. Yeah, that makes sense. We've eliminated those, so -1, the only other choice is -1. Now you could be explicit here if you wish. Sometimes it's easier to understand the code. Explicit mean that we are testing for less than 0, which would be all negative numbers. Oh, I need num. That's why it's giving me static. There we go. So this will be the same result as what we had before, but it explicitly shows you by the code what we are testing for. I added a text cell. Is it odd or even? Once I leave that cell, it puts it in there. Do I press enter? No. It goes somewhere else. All right, so I'm going to add code. And here's the code I have from another program. How do we determine if... Whoops, wrong. All right, this is the one I wanted. This is the modulo operator in Python. It returns the remainder of integer division. So integer division is, for instance, 1 divided by 3. Well, 1 divided by 3 is 3. I'm sorry, it's 0.33. Let's do 4 divided by 3. 3 goes into 4 once. Right? With integer division, you don't have 1 point whatever, you just have it once. This is how you do integer division in Python. The remainder of that integer division is 1. So the remainder of whatever number we type in, modulo 2, if it's even, it's always going to be 0. If it's not even, it's going to be 1, which is this other case. So if we run this, if I enter 3, it's odd, because 3 modulo 2 does not equal 0, it equals 1. If we run it again and put in a 1, 2, 2, 2, 4, it's even. So we either have one or the other. Much decision making in Python is one or the other. Now, besides comparing floats and integers, we can also compare strings directly in Python. So if I was to say Dodge is the truck, and I did not have this in there, the user would have to type in Dodge exactly as it is, all lowercase. Well, not everybody necessarily types in things correctly, so there's a method called lower, which converts this into lowercase, and then we end up with Dodge. There, you have a Dodge truck. Without this, it's going to try to compare, because programming languages are case sensitive. It's going to say you don't have a Dodge truck, even though it does say DODGE. The dot lower converts it. The dot lower method converts it, and we now have a Dodge truck. Now we have a grades application. This is a solution, but it is not the best solution. The first part is fine. If the score is greater than or equal to 90, you get an A. And then we're done. However, with this, where we use if, we have to test this, we have to test this, we have to test this. A better way to do it, and we've seen that previously, is to use an elif. That means that it's either this, or this, or this, or this, or this. Because we only want one, we can only have one decision coming back as true. There. So if our score is 100, we're done. If our score is 65, test, 65, we print that. If it's 50, well, you flunk, because there is no other choices. We don't have to say less than or equal to 60, because there are no other choices. This takes care of everything above 90, above 80, less than 90, because 90 is gone, 70 to 80, 80 is gone, so we don't care, 60, and then everything left over is below 60 and below. So we don't always have to do every single test. A classic program for every programming language is the guessing game. We're going to generate a random integer between 1 and 10. It's inclusive, meaning we could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gets assigned to here. We pick a number, hopefully guessing this number. If our guess is correct, ooh, we win. If our guess is incorrect, ooh, we lose. Well, we're going to take this, because you can only play it once, and add a loop to it, I think next week. Yeah. So let's run it now and see how exciting this is. This is the first game you've ever programmed. Uh-oh, well, we blew it. Now if we run it again, guess what? Every time, oh, actually I got it that time. Every time you have a same amount of chance to get any of the numbers. There, the number's 8, I lose. So there is the beginning and the end. The last one, the assignment, is just a very simple little fun assignment. You may or may not like Taylor Swift. She's not really, I'm not into that, but you could substitute anything in here that you wanted. We are going to test a single variable for a range of values, much like we did with the grades. If they're over 21, they can enter and have a drink. If they are between 8 and 21, they can enter and can't have a drink. Well, we've tested for over 21. Do we have to test for over 21 again? No. We just have to test for 18 and over. Otherwise, they're too young. So this shouldn't be too bad a problem. It should be pretty easy. Let's see what you can do with it.